Good morning. Today we are covering section 2.8. We are graphing linear inequalities in two variables. So linear inequality, we have an inequality. It's just the same thing as we saw in linear equations, but now we are dealing with an inequality. We have an in less than or greater than instead of an equal sign. In our pair, x and y is the solution of a linear inequality if the inequality is true when we substitute the value of x and y. So for example, number 1, determine whether the given ordered pair are solutions of y is less than negative 9x plus 7. We are going to substitute the value of x and the value of y into the inequality, and if it's true, it's a solution. If it's false, it's not a solution. We have y is less than negative 9x plus 7. So instead of the y, we're going to plug in a 10. Instead of the x, we're going to plug in a negative 1. We are going to simplify. 10 is less than negative times negative is a positive 9 plus 7 is 10 less than 16. True. So this is a solution. Yes. Go and try example B and C. See what you get. Go ahead and pause it and see what you get for example B and C. So for example B, we're going to plug in the value of x and y. We have y is less than negative 9x plus 7. We want to find out if this is a solution for the inequality. So we're going to plug in the value of y to be negative 2. The value of x will be 1 and then plus 7. We are going to simplify. Negative 2 less than negative times the positive is a negative 7. Negative 9 plus 7. So negative 2 is a less than negative 2. False. Negative 2 is equal to negative 2, not less than negative 2. So this is not a solution, so no. And for the last one, we have y is less than negative 9x plus 7. We're going to plug in the value of x and y. So instead of the y will be a 3. Less than negative 9. Instead of the x will be a 2 and then plus 7. We have 3 is less than negative 18 plus 7. 3 is less than negative 11. Is that true or false? That's false. 3 is not less than negative 11. It's greater than negative 11. Now, to graph linear inequalities, there are two ways of doing graphing linear inequalities. One, we need to be able to first graph the line, and then we can test a point on either side of the line to see if it's a solution or not. That's one way. We're going to do it in a slightly different way. It's a little faster. Now, the symbols that we have are less than or greater than. Remember, before we used to have an open dot, but because we are doing on an x and y axis, this is going to be a dashed line. That means that all of those points on the line are not part of the solution. If it's less than or equal to, greater than or equal to, it's going to be a solid line. That means that points on the line are also part of the solutions. Example number 2. First, we need to be able to graph the line. So let's go and solve for y. I'm going to move my 2x to the right, becomes a negative. We have negative y is greater than or equal to negative 2x minus 3. I need to leave the y by itself, so I'm going to divide by negative 1, divide by negative 1, divide by negative 1. Negative, negative cancels. Y, when we divide by negative number, we have to flip the inequality. Negative and negative becomes a positive. Negative and negative becomes a positive. We are going to graph it. The y-intercept is 3. My slope is positive 2 over 1. So I'm going to go up 2 and to the right 1, up 2 to the right 1. Or I can do the opposite, down and to the left, down and to the left, down and to the left. I'm going to connect all those points. This line, because it's less than or equal to, is going to be a solid line. That means that the points on the line are also part of the solution. If it's less than, we are going to be shading the lower part of the graph. And I want you guys to place arrows going down. That will tell you which part of the graph to shade. Now be very careful. Some of you guys will go over to the original graph and say, oh, this is greater than, so I'll be shading the top. But we need to be able to leave the y by itself. We are shading the bottom of the graph, less than. Let's go and try example number 3. First, leave the y by itself. So I'm going to move the x to the right, becomes a positive. We have negative 3y is greater than positive 2x plus 6. We are going to divide by negative 3, divide by negative 3, divide by negative 3. The negative 3's cancel. And when we divide by negative number, don't forget to flip the inequality. That'll be negative 2 over 3x minus 2. I'm going to plot the y-intercept, which is negative 2. My slope is negative, so I'm going to go down 2 and to the right 3, down 2 to the right 3, or the opposite, up and to the left, up 2 to the left 3. Now connect all of those points. And this is going to be a dashed line. That means that the points on the line are not part of the solution. Now, if I look over here, this is greater than, but remember that it's a negative y. So once I solve for y, I'm going to have to flip it. So that means that I'm going to have to shade the bottom part of the graph. I need you guys to draw 2 arrows going down. So that means I'm going to have to shade that section of the graph, the bottom part. All of those points that are shaded are solutions. So if you plug in any of those points that are shaded, that will give you a true statement. Now let's continue with example number 4. On example number 4, we have x is greater than or equal to negative 3. Remember, whenever we have x and equal to negative 3, it's a vertical line. It has to cross that y-axis, or it has to cross the x-axis at negative 3. And all of those points on the vertical line, the value of x is negative 3. This is going to be a solid line. And I'm going to be shading the values that are greater than or equal to negative 3, which are the numbers to the right. Go and try letter B. Go and pause it and try letter B by yourselves, and then we can check. For letter B, y is less than 2, so it has to cross the x-axis at 2. That's going to be a horizontal line, and we are going to make that a dashed line because of the less than. Remember to place arrows on both sides. And we need to shade the values are less than 2, which will be on the lower side. Some of you guys might want to test the point and then decide whether to shade the top or the bottom, which is perfectly okay. And that'll be the solution. And let's go and work out the last example, example number 5. Grab the following linear inequality. Try it yourself and see if you guys can, we can check and see if you got it correct. Go and pause it. So for example number 5, I first need to leave the y by itself. Now even before I start, this is less than And I will not have to switch the inequality when I solve for y, so I will end up shading the bottom part of the graph. Let's go and leave the y by itself. So we have 2y is less than negative 5x plus 6. I'm going to divide by 2. The 2's cancel. So we have y is less than negative 5 over 2x, then plus 3. The y-intercept will be 3. My slope is negative, so I'm going to go down 5, 3, 4, 5, and to the right 2. 2, 4, 5, and to the right 2. I can do the opposite, and it'll be right over here. In this case, the line will be dash, because it's not equal to. That means that all those points on this line are not part of the solutions. And I need to decide whether to shade the top or the bottom. This is less than, so I need to shade the bottom. I need you guys to place 2 arrows. And I want to make sure that I see those 2 arrows on your homework to verify that you're doing it correctly. So I need to shade the bottom part. Make sure to shade all the way through the graph. All of those points are solutions for the inequality. Thanks, and make sure to email me if you have any questions. Have a great day.